12, 11. 12, 11. Blue. Great minds, huh? So this is the second of the three methods. Substitution, we'll get this out of the way. If this were the first time that you'd ever seen this before, the lecture would be more lengthy, but it's not the first time you've ever seen it. So this will be relatively brief. So yesterday, the one we talked about is where we graph two lines and see where they cross. Easy peasy. Today's method is completely and totally different from that. So let me put the first example up here, and then I'll ask first of all if you by chance remember how to do it, and then I'll go through it with you. Got three examples. There you go. I'm just throwing it out there. Anyone by chance remember how to do substitution? It does not involve graph paper at all. Not a clue? Yeah. You don't? You substitute something, but you have to have something to substitute. So go ahead. Yeah, you'll remember this one is the box method. Every time I teach it, I use a box. So what we're going to do is we're going to look through, and I will never ask you to use this method if it's not under the right circumstances, because with all the three methods at our disposal, I'm never going to ask you to use the wrong one, so to speak. So all these examples and all the assignments problems today are going to be set up. I want you to notice that there's one variable here, that guy, that does not have a number with it. It has a 1, I get that, but it's already kind of quote unquote by itself. So what we're going to do is we're going to very purposely select the bottom equation, and we're going to go off to the side, and we're going to set it up so that x is by itself. And because we're trying to create something that we can substitute into the other equation. So if I get x by itself in the bottom equation, I'd have to add that 3y across, and I would get x equals positive 3y and positive 8 like that. Good so far? So what that means is that X now has an alias. X now says, I can go by a different name. You can call me X, or you can call me 3y plus 8. Because an equal sign says that. An equal sign says that the thing on the left and the right are the same, right? You can call me by either name. So what I'm going to do is I'm going to take the contents of that red box, and I'm going to, here it goes, substitute that quantity into the other equation and replace X with his new nickname. So the red box quantity is going to go right there. Always make sure you substitute into the other equation. If you substitute back into the one that you used to create the box, you're going to get an identity, and you'll make no progress. It'll just come out to say like 10 equals 10. And you'll go, what do I do now? Well, that happens when you substitute badly. So we're going to take the bottom equation to find our box, and then resubstitute the box into the top. And the new top equation is now going to say -3, awkward void where x used to be, plus 3y equals -12. So again, we are substituting where it used to say x. We're going to put in x's new nickname, which is 3y plus 8. And the reason we do that is because it creates an equation that doesn't have two variables. It creates a very simple algebra 1-y kind of situation here where we can solve. Okay, so that's the substitution process. Not done, but that's really kind of where it gets its name, is from there. So now we're going to take this lower equation and we're just going to solve it, right? We're going to use our skills that we've acquired over the years. Step 1, obviously, is to distribute. So if we distribute, we get -9y minus 24 plus 3y equals -12. Anyone confused? We good? Okay. So now we're going to put our y's together. The -9y and the plus 3y are on the same side of the equal sign, so we just combine them old school, right? Put them together. And then I'm going to go ahead and add the 24 to the other side. Okay, we can do a couple steps at once, like we're tough. Everybody okay? And then we're going to divide by -6, and we're going to get our answer, like half of our answer. I always say with this method that we're halfway done, but we've done 90. We're halfway done, but we've done like 90% of the work, right? You with me? So like all the hard work is done, but now we're just, I say halfway done, which is kind of always a weird thing to say, but the answer has to look like this, right? Like we know now that y is equal to -2. So knowing that, I can write my answer over there. And then what I do is I take that half answer and I always put it back into my box. Some people don't. Those people are, I think, kind of weird. So, and I've had students, I've been teaching it this way for a long time. And some students don't draw the box and they do just fine. But if you ever find yourself struggling, I'm telling you, that physical box is a nice focal point for this problem. We use it in step one to plug it in, and then we use it again now to find our second answer. It is the easiest place on every problem to find the second answer because all I have to do is substitute. So if I take the yellow number, -2, and I put it right where that purple arrow is pointing, then all you got to do is like some fourth grade math to figure out the other answer. So up here, what is 3 times -2? And what's -6 plus 8? And we are done. So we can say that that would, if we did graph, that would be the point where the lines would cross. But in this case, the context is more that those are the x and y values that simultaneously solve the two equations. So again, I can speak for everyone except 3 of you that you have all seen this before. For you juniors, it was 2 years ago, and for you freshmen, it was last year. So hopefully that rings a bell. All right, so a couple more examples for you, just two. Didn't feel today like you needed 7 or 8 examples. So this is pretty simple stuff, and we will use this method again when we get to our nonlinear systems, when we have like a quadratic equation in a system with a linear equation, we can often use this method. So you'll see -9x plus y. So who's our target variable this time? Yeah, the bottom y for sure is our guy. And again, I'm not going to ask you to use substitution and not make it feasible. So if I gave you like -7x minus 2y and -9x plus 3y and then said use substitution, that's just not right. I won't do that to you because it's not a sensible method to use. So we're again going to target the bottom equation. And there's nothing about the bottom. I just realized now with my note card that I wrote them all so the bottom one is our guy. Don't think that it has anything to do with anything. You just go find the most friendly variable. So if we take the bottom equation and we get y by itself, what would it say? 9x minus 16. And I always have, and I always will draw the box. To me, it's something to hold on to. It separates for me this method from the other method that we're going to learn either tomorrow or Monday. This is what identifies for me substitution as the box. And where am I going to put the box? In the y in the first equation. Yeah, so whatever variable I got by itself is the one I'm going to nickname out, right? So since y says, hey, I have a new name, you can call me 9x minus 16, then I'm going to take and put it right where y used to be. And the top equation will now say -7x minus 2 times awkward void equals 7. Good. And into that awkward void, we're going to put the contents of the box, 9x minus 16. And as always, look what we did. We created an equation that we can solve. Can we still make mistakes? Yeah, I mean, I proved it in the last one. I was trying to talk while I wrote. You think I'd be good at talking while I write, and I divided like a knucklehead. So just be careful. So -7x minus 18x plus 32. And then feel free to do multiple steps at once. How many x's do we have? Yeah, but that's never what I mean. Yeah, we actually have -25 x's. I knew what you meant. We got 2 terms, right? That question always comes out wrong. And then if we subtract 32 from both sides, what's 7 minus 32? -25. And when we divide it out, we get x equals 1. So again, that's not the answer. It's half of the answer, but that half of the answer has been accomplished by doing, again, 90% of the work, right? And what do we do with the one? Put it back in the box, back in the box, back in the box, back in the box, back in the box. Always, I mean, you could put it back up over into the system, but like, bless you, why would we do that? Like, because then we got to solve another equation. So never, ever, ever fail to appreciate the box. So we're going to put one right there. What's 9 times 1? 9. And 9 minus 16. And we, again, are done. Okay, I have one more example because it just is something that people always ask about. So I thought I'd go through it with you. And then I will say this, that on your assignment, I made sure that the computer generated only questions that have nice answers. So it's a nice way as you go through an assignment like this to make sure that you're doing things right, is to make sure that if you get like 12 divided by 5 at the end, you did something wrong, because all the answers are nice, like -2, 0, 9, 3, stuff like that. So here's your last. Here, I'll just switch the order. That's what I'll do. And eventually, tomorrow or Monday, when we relearn elimination, you would see that this is actually a better system for elimination. But because we're practicing substitution today, that's what we're going to use. So who's our guy? Top Y for sure. Well, the bottom Y is not terribly unattractive, but what makes the top Y better? He doesn't have a negative, right? So I'm just more automatically sort of attracted to the top Y, but you guys are tough. Like if you wanted to do the bottom Y, you could. I'm not going to. So I'm going to take the top equation and I'm going to get Y by itself. And it's going to say Y equals what? -2x minus 5, because the 5 doesn't move, so it stays as a negative, right? And again, I will box. And my box for me is a real focal point, always has been. And I'm going to take the quantity that's in the box, and where am I going to put it? In place of the Y, in the other equation, right? In this case, that's the bottom. So this boxed quantity is going to go and replace this Y right here. And the reason I wanted to do this example with you is because you still need your parentheses here, because there's a minus. I will say, if this minus right here that I'm kind of moving my pen around, if that had been a plus, then you wouldn't need parentheses, because plus a quantity doesn't require parentheses, right? But a minus, don't disrespect the minus. It is minus the whole quantity, and that's a minus or a negative that has to be distributed. So make sure you give it its due respect, the negative sign, okay? And then if we put the boxed quantity in there, the boxed quantity is -2x minus 5. And again, we did it. We created an equation that we can solve. You cannot solve equations with 2 variables, but you can solve them when you get them down to 1, which is why we do this. What's our new equation going to say? 3x plus 2x plus 5. Love it. And then the math, again, feel free always to do multiple steps. We're at that point where we can do that kind of stuff. How many x's? Good answer. 5. And take away the 5, what do you get? And then divide by 5, and you get your first half. So I like to write my answer. I like to construct it like this and leave a blank. And then to find the other one in the blank, where do we put that -4? In the box, 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 in the box. Go back to the box. So if you take your answer -4 and put it in the box, what's -2 times -4? And what's 8 minus 5? And we are done. There you go. So that's how you do substitution. So today you're going to have tons of time. They got like 32 minutes or something like that. And you're going to work on yesterday's assignment and or today's assignment and try to get it all done if possible. Good. All right.